In this video, I want to go over the two your turn questions in this section on motional EMF. In this section, we learned that an EMF was induced whenever a bar was moving perpendicular to a magnetic field. So let's take a look at this question. It says that a metal bar moved through a magnetic field. So which way is the induced EMF going to be? So where are the positive charges going to be? Where are the negative charges going to be? So we're going to use the right-hand rule, number 3 again. Let's see what happens to a positive charge that's right here in the middle. It's moving down, so you're going to point your fingers down, and then you need to fold your fingers so that they point in the direction of the magnetic field. Oops, missing a finger here. So that means that I actually have my palm facing me here, because you have to fold your fingers towards you, because that's out of the page. And that's how you know that your thumb is going to point to the left. So that's going to be the force, right? The V was down, but then you folded those fingers towards you. Very hard to show, but that's right-hand rule number 3. So the positive charges are going to experience a force to the left, which means that the negative charges are going to experience a force to the right. So the separation is going to be this way, and you're going to have that delta V that we learned about induced in your bar. Sorry for the bad picture here. Let's take a look at one more question here. So it says that we have an induced current flowing clockwise as the bar is pushed to the right. So which way was the external field? So this is where we have motional EMF, and our bar that's going to have the EMF induced is attached to a loop, so we know that there's going to be a current induced. Okay, so let's figure this out here. We can use Lenz's law. All right, let's try that. Lenz's law says that the induced current is going to oppose the changing flux. So we don't know which way B is going. All right, we don't know, but we know that the flux through this loop here is getting smaller. It's decreasing because as the bar moves to the right, the size of the loop is getting smaller. So there's an external field all throughout here, but if the loop is getting smaller, there's less and less field going through it. So we know that the induced field is going to be in the same direction as the applied field when the flux is decreasing. Since we're given the induced current, which is clockwise, then which way do our fingers have to point? Use right-hand rule number 2. Right, the fingers have to curl in the direction of the current. The thumb is the direction of the magnetic field. So if you curl your fingers clockwise, use your right hand, you might twist your arm a little bit, but your thumb is going to be into the page. Oh, that looks really bad. If you curl your fingers clockwise, your thumb is into the page. This was the induced current. The induced current is creating a field into the page. That means that the original field was also into the page because the flux was decreasing, so the induced field had to point in the same direction as the applied field. And we can also do it another way, right? Right-hand rule number 3, and figure out, well, if the induced current is going to be clockwise, that means that the positive charges were accumulating over here, while the negative charges were accumulating over here, because that's what would cause a current to go this way. So that means that if you had a positive charge in here, it experienced a magnetic force upward. So we use right-hand rule number 3. If this charge is moving to the right, then you put your fingers to the right, And you can see that in order for your thumb to point up in the direction of the force, then your palm is facing away from you. You can fold your fingers into the page in the direction of the magnetic field, right? Your fingers are V, you fold into the direction of B, which is into the page. Your thumb is the force. So that's another way to see that the magnetic field had to be into the page in order for the magnetic force to be upward, so that the charge separation would be this way, so that the induced current would be clockwise. So that's it for the couple of your turn questions related to motional EMF.